Okay, and we are live once again. So this is actually going to be the last time we're going to be live for a long time, maybe. Let's see. So after 14 hours streaming, actually, well, first 13 hours, going to be 14 by the end of this session. We're going to end Generation 2020 online. So thank you everyone that's been with us for the entire thing. It will really great to be here. And for the final session, which is also a keynote, I'm really happy to welcome Venkat. Hello, Venkat. How's it going?
Very good. Thanks so much for having me and for all the hard work for the entire team. I really appreciate it. And thanks to everyone who joined as well.
I mean, it's our pleasure. So it's really happy to have you here again. So you did open our keynote last year physically. Now you're closing your keynote on 2020, but online. So we're still really sorry that has to be that way, but we will really like to have everyone in Portugal. But I think these have to do, right?
Well, absolutely. It's great pleasure to be here. I hope everyone is safe. Thanks again for the opportunity to speak. So I want to talk about something that is very important for what we do as a profession and as the professional. So I want to talk about speed without discipline is a recipe for disaster. This is purely to reconfirm to organizations that are investing time and effort and to really inspire and excite others who are not doing so already but are considering. So let's talk a little bit about a few things that we often go through. What are the latest buzz? I was kind of looking around for what people are talking about. And we hear things about microservices. We talk about big data. We talk about cloud. We talk about Docker, or is it Moby, or whatever name we want to give to things. Is it functional programming that we are excited? Oh, it should be Angular 2. Oh, is it 4? Oh, it's actually 9. Or is it IoT? Or is it AI? Is it algorithm? I was listening to something on the TV, and something has gone mainstream if they use the word algorithm on the TV shows. And that's where we are right now. And of course, machine learning. And then recently somebody told me machine learning is not exciting. It's actually advanced machine learning. Well, we're really in this world of buzz that we live in constantly. But if you really look at all of these things together, it really comes down to higher level of abstraction. That's what we are doing. I've been programming for a few decades now, and every a few years I look at what we do, and clearly there's one thing that's consistent, and that's we are building on higher levels of abstraction. And of course, we are on the cusp of yet another major change in our industry. Well, if you really look at the 1990s, the paradigm shift of the 1990s was a big deal. I was a child programmer back then, young programmer, if you will, getting into the industry, and I saw the acceptance of object-oriented programming. Even though object-oriented programming was introduced back in 1967, it took 20 plus years for it to really become popular and mainstream. And of course, we went from the structure to object-oriented programming. Now, what is the latest paradigm shift we all are excited about? And I'm going to say that is from imperative to declarative style of programming. Now, you may look at this and say, oh my goodness, are you serious? Is it not functional style of programming? No, I'm going to say it is declarative. So the difference between imperative and declarative and not just functional. But why is that? And the reason for that is in the case of imperative style of programming, we tell what to do and also tell how to do it. In declarative programming style, we tell what to do and not how to do it. Well, as it turns out, functional style of programming is a subset of declarative style of programming. So every single time we write code in functional style, we are writing code in declarative as well. So the relationship really is the functional style is actually declarative style plus the use of higher order functions. And that's one of the reasons why I'm excited about declarative style is because it encompasses the functional style as well in terms of how we program. Now, one of the reasons why I'm really excited about this is not just imperative versus declarative style of programming. I'm going to say it is imperative versus declarative style of living. And if you really look around the lives that we live today compared to 5 years and 10 years and 15, 20 years ago. I often reflect on this with my family. We talk about the way we used to do things 20, 30 years ago and the way we do things today. And we are moving towards a declarative style of living. Let me explain what that really means. Well, in imperative style, we tell what to do and also how to do it. Let's take a look at an example here real quick. Suppose we have a bunch of names, Dory, Gil, Bruce, and so on. And what we want to do here, let's say, is count the number of names that are going to be a letter, let's say, 4 letters characters. So how do we really count the number of 4-letter characters in this particular case? Well, the answer to that is we could say count is equal to 0. And when we are done, we want to display the value of count, which is, of course, the number that we are going to find in here. But we can start by for, and then we could say I equal to 0, and then I less than names dot length, and then, of course, I plus plus, and then we could write the code like this. Now, thankfully, even languages have gone a little bit better in their ability to do imperative style of programming. So we could say name of names and reduce the burden just a little bit, if you will. But then we could say if the name's length is equal to, let's say, 4, we can then say, in this case, we want to increase the value of count, and we can increase the count, and it gives us a value of 3. Well, that's an imperative style of programming where we have to do every single thing is our burden we have to do. Declarative style is where we can focus on the what and not get bogged down by the details of the how. So if you want to write that code in the declarative style of programming, we can do that very easily. So we can get rid of all of that nonsense we did. And we can simply say, for example, in here, we could simply say, well, names.filter, and given a particular name, we can say name.length is equal to 3, or rather 4. And then we can ask for the length on it, and then we can get the results out of it. So as you can see here, the code becomes a lot more concise. So we do less effort. We also write code more concisely as well. And so that becomes more of a declarative style of writing the code. Now, clearly, that's at the programming level and functions and logic that we are talking about. Now, declarative, of course, is where we reduce the burden, as we saw here. But of course, declarative nature is not just in programming at functions and classes level. It goes a lot further than that. Let's talk about declarative style of programming on the front end. Let's just step back for a minute and talk about front-end programming, if you will. But what is really front-end programming? What does it really boil down to? It really comes down to 2 things, isn't it? One is we use Ajax to get data from the backend. So you make a request to the server, and the data comes back from the server. Plus the use of a DOM API. So DOM manipulation is what we normally do. So really, front-end development today is using Ajax and manipulating the DOM. Now, how many of us are absolutely excited about manipulating the DOM? Well, if somebody has never manipulated the DOM, maybe they get excited on the first day. And after writing the code for a few hours, we realize the job to manipulate the DOM should be given to people in the prison, and nobody in the free world should be forced to do it. Why is that? Because it's really verbose, cumbersome, error-prone, really hard, way too many moving parts, a lot of work that need to be handled. Now, if it really comes down to it, where has the world gone in general? I'll draw an analogy here about driving cars. I do a lot of different things, but I will guarantee you one thing. You will never, ever catch me driving a stick shift car. I still, with all respect, I still cannot understand why any human being will subject themselves to riding a stick shift. They sit there and keep moving this clutch over and over and over. That's definitely not for me. So if you really think about it, driving a stick shift car is kind of like manipulating the DOM API. You say get element by ID, you use the properties, the entire DOM API. My gosh, this is horrible way of living, in my opinion, definitely on the DOM API, manipulating the DOM with the DOM API. Now, on the other hand, if you really think about it, we could probably bear with auto transmission. Now, auto transmission is not that bad if you really think about it. And in auto transmission, what do? You put it on drive and you take your hands off the clutch and you can simply be driving. You can even put it on cruise, but you're still driving the car and it's a lot more bearable. Now, what does that really feel like when it comes to developing web applications? I'm going to say that is your jQuery way of programming. Now, jQuery, it doesn't remove the burden. I call it the morphine of programming. It reduces the pain for you. The symptoms are still there. You don't feel the pain until the medicine wears out. That's basically using jQuery. But honestly, though, I have kind of moved on a little bit further in what I normally do. If you really think about it, you could be doing inner HTML or doing get element by ID. That is like your stick shift programming. But the world has moved on to use things like Angular or React or or Vue. And if you really think about it, you are saying in this is kind of like the jQuery API, but you are saying, for example, this is Angular. You say selector is greet and template name, how are you? And you're not manipulating the DOM. You're simply saying, hey, here's the DOM, here is the data, you go do the work for me. Now, how does that really feel like? I was mentioning earlier that you would never catch me drive a stick shift. And of course, an auto transmission is just a little bit better. But most of the time, these days, I'm more of an Uber and a Lyft kind of person. I would just get out of the airport, flag down, or call in for a Uber or a Lyft, and I would just get into the back seat. While the driver is driving me around town, I will sit back in the back seat and do what I really like doing, which is to write code. So, in other words, like using Uber or Lyft, if you will, that is kind of like using Angular or React or Vue. And so that's a higher level of abstraction that we really are dealing with. So in essence, we have moved towards this higher level of abstraction in almost every aspect of what we do. This is, of course, declarative. As we know, we can really focus on what we want to do and let the underlying libraries or implementations deal with the how of actually how to do it. So that's basically the world we live in, moving in that direction. But what is the impact on us because of that? Well, the code becomes expressive, it becomes concise, it becomes maintainable, it's less effort to maintain in general, it's rapid change, we can quickly get in and make changes to the code, and we can turn around very quickly. It really comes down to the economics of software development. And that's one of the things I want to emphasize. I often think about the economics of software development. What does it cost to develop the code? But more important, what does it cost to maintain the code as well? Now, in that regard, we are living in a very fast changing world. But let's talk about JavaScript just for 1 minute. We all have used JavaScript and we have a mixed feelings about JavaScript. Now, JavaScript is truly a black swan in our industry. Black swans are events we never expected, but they change the world around us in a way we never think about it. Unfortunately, we are living right now in our society among a black swan, which is the COVID-19 situation we live in. So the pandemic is a black swan, but as we know, there are good black swans and bad black swans. We can say the pandemic is a bad black swan. Google and iPhone, maybe we could say, are good black swans. What about JavaScript? Well, okay, you decide whether there was a good black swan or a bad black swan, but it was a black swan nevertheless. But how do we, work with JavaScript? All of us have used JavaScript, But how do we really work with JavaScript? It's like the chainsaw, isn't it? You got to be extremely careful. You can't just turn it on and swing it around. It could cause in a lot of result in a lot of damage. We got to be very careful. And one day I wanted to think about how to describe JavaScript. And here's the best description I could come of JavaScript. I said JavaScript is like an infant. It is cute to play with, but you have no clue why when it begins to cry. That's the way I feel about JavaScript a lot of times. It is amazing, it's powerful, and yet when it goes really bad, it takes a lot of effort to figure out what really went wrong. Part of the reason for that is it's not only dynamically typed, it's a weakly typed language as well, and that causes quite a bit of problem. So to me, programming in JavaScript is a slippery slope. It is something extremely powerful. I love the language for what it can do, but at the same time, we got to be very careful programming in it. But of course, every one of us today talk about being agile. But what does it really mean to be agile? I mean, have you walked into a company recently where they said, we don't do agile? Well, everybody wants to be agile, do agile, but that doesn't mean they're doing it right. But what does it really mean to do agile development? It is actually about our ability to respond to change even late in the development process. And that is one of the things that truly means agility to me, is to be able to respond to change. Now, I'm not suggesting we should be able to respond to change without any repercussions. There is always a cost involved, but it is our ability to reduce that cost and the unpredictability of change as much as we possibly can. And that's what we really want to hope for by doing agile development. Now, what does it really mean in reality to be agile? Well, unfortunately, there's this concept, and then there is the reality of what we actually do. You know, I go to a lot of companies to consult and help, and in some companies, they would tell me as I walk into the door, they will tell me, oh, Venkat, we are agile. And I always tell them, I'm so glad we can get that out of the way. Now let's talk about what we actually do. Now imagine this for a minute. Imagine that you are working for a company where you are a project manager, you decide to do agile, and you hire a team of programmers and say, here are features, implement it. Well, they implement the features. You take it to your customers and say, hello, folks, look at what my team developed. They look at the features they developed, the team developed, and do they ever come and hug you and say, oh my gosh, that's exactly what we wanted? Well, oftentimes they look at what we did and say, let me tell you what they should really do. Why is that? That's because software exhibits what's called an observer effect. An observer effect is where the minute we observe something, we want to change it. And so software often exhibits the observer effect, and we need to be able to respond to it. In fact, I would argue if your goal as a team is to develop what your customers wanted, you will fail. Instead, what we want to do is we need to develop what our customers still want. And in other words, they want to change what they want, and we should be able to respond to it. Now, within reason, obviously, but we need to be able to work towards that. So the question is, how can we get to that particular point? Now, in this case, if we go to the team and say, hey, look at what the team has developed, the customers look at us, give us a certain changes. We go back to the team and say, make these changes for me. And then we take it to the customers and say, ta-da, we made the changes. Has it ever happened that something that worked before doesn't work anymore? Well, all the time, isn't it? Well, why is that? Well, the reason is when we make change, software systems, this is the peculiarity of what we work on. And I'm going to say software systems are non-linear. And what that means is we could change something here and something will break over there. It's a non-linear system that we work with. And when we work with non-linear systems, these kinds of changes where maybe this overwrites some memory, or this occupies more memory, or the buffer runs out, whatever that could be, and then we have trouble because of that. So the team realizes, oh my gosh, this worked before, this doesn't work anymore. So this becomes really hard to maintain the software. Well, it erodes confidence over time. And then what happens? The boss comes to us and says, make these changes, fix these bugs, and make these enhancements. And then when we say we are done, they ask this dreadful question. Nobody likes this question being asked, isn't it? What do they ask with us? They ask us, does it work? And what do we respond? We respond with this beautiful sentiment, and that is called, I hope. Now, this sentiment of I hope it works, there's a technical term for it. That term is called JDD, which stands for Jesus driven development. And that's what we do. We put faith in the Lord and say, Dear Lord, please let my code work. Don't get me wrong, I do have faith in the Lord, but I think the Lord is way too important to be spending time on the silly code I'm writing. I would rather focus on the other approaches that give me the confidence and the feedback that things actually work. Now, I was actually looking at some software the other day when I tweeted this, and it is, don't bother testing software. If it does not work, your users will tweet about it. Now, this is the shameful world we sometimes live in. We keep hearing complaints about software on Twitter rather than the teams taking responsibility to build quality software that actually works. And as we are constantly enhancing software, how do we know it actually works? So yes, speed is important, but I care about something beyond speed. And while speed is, important, I want to emphasize what I really care about is this thing called sustainable. So sustainable speed. And to me, sustainable speed is what I really focus on. So I don't want to go at a breakneck speed because I might actually break the neck doing so. So I want speed which is manageable. I want speed that's sustainable. So sometimes we may have to slow down to gain speed. And the question is, as developers and technical people, we should ask the question, when is the right time to slow down so we can gain the speed? And as a result, we can sustain the speed of agility over time. And so I'm all about this sustainable speed, not breakneck speed. So, but who is a software developer? Now, I often say this is the best job in the world. Now, why is that? Because my definition of software developer is a profession where people get paid to write poor quality code and get paid more later on to come up and come back and clean up the mess we created. This is the best job. Would you do this to a plumber? If a plumber walks into your house and creates a mess and leaves, would you hire the same plumber to come and fix again? Well, but that's what we do to programmers. We hire programmers, they create a mess, and we pay them more to come and fix it. Well, this is great, isn't it? Because as long as they don't complain, why bother about it? Well, the answer to that is ethics. I care a lot about professionalism and our ethics. Unless we decide to do better, the world is not going to force us to do better, at least not yet. That might change in the future, but I would rather not wait for that. So I want to really focus on how to create sustainable agile development, sustainable speed. Well, one of the ways to do that is to focus on testing. Now, there are other aspects to it. I don't want to emphasize testing is the only thing, but testing is something I care a lot about, and I invest a lot of time and effort towards it. So, testing. But what about testing? I'm going to say I love manual testing. Now, this may surprise some people and say, oh my gosh, are you serious? Are you going to just click away and then run the code to see, what it is doing? Oh, yes, that's exactly what I'm talking about. But I want to emphasize what the word testing means in my definition. Now, what is testing? Testing to me is an act of gaining insight into the application. I want to know about the flow of the users, through the system. How do the user interact with the application? What about performance? Hey, are there steps we can eliminate? Is the view better? Can we rearrange the UI? Can we optimize where we deploy this and see if that makes more sense? Let's think about the user experience. To me, those things are testing. Wait, but what about I wrote this code yesterday and it seems to have worked? Does it work today? That to me is not testing. That to me is verification. So testing versus verification. So verification is it worked yesterday. Does it work today? That to me is verification, not testing. So I'm going to emphasize no human should ever be asked to manually verify if the code works. I would take that as an insult on humanity. How dare, how shameful that somebody would ask us to run the program and verify that it works today when it worked yesterday, or it worked in the morning. Does it work still today? No human should be subject to that kind of poor treatment, in my opinion. So, in other words, test manually but verify automatically. So most of what we do is not software testing, it is software verification. I develop applications for myself, for my company, for my clients, and one of the things I emphasize is I want to verify the software is doing what it's supposed to do automatically. I write the code, and on the side, my tests are constantly running and giving me feedback right away that things are still working. Or if they don't work, I want to get a very quick feedback that things are falling apart. I don't want to manually verify to get that feedback. To me, feedback is extremely important. So when verification is what we are focused on, I'm going to say there are three phases of verification I see in the industry. I work with companies around the world, and part of what I do is I focus on agile development. But I want to emphasize when I focus on agile development, I don't focus on Scrum. I don't focus on the management related, process related activities. I call myself the technical agile coach. I work with teams on technical practices, not on the process practices. When I go to companies, I see three groups of companies that are out there. The first one is no automation. These companies are in denial. They are not taking time to automate. They have just written the code and they click away and then manually verify software. This is expensive. And I remember working with one company, I'll just be vague about it, in the northwest part of the US. And when their manager called me, he said he has lost the ability to predict when the bugs will get fixed on his product. He would say, when we give a bunch of errors, a bunch of bugs to fix, the team would come back with bug fixes, and we will end up with more bugs now than we started. And he says, I threw my hands and I told my management, I have no clue when I will be able to release with no bugs, or at least no known bugs, because every time we touch it, we got more bugs coming out of this. Well, that's really a sad situation to be in. But unfortunately, though, to move from that takes a little bit more effort, or a lot more effort, at least a lot more skill. The second group of companies I've seen are the ones that have said yes to automation, but what do these companies do? They go hire an automation engineer. What a lovely title. Hey, automation engineer, we have hired you. Your job is to automate the testing. Well, Bob is the automation engineer, joins the work, and comes to the team and says, hello, folks, I'm Bob, your automation engineer. The programmers are busy coding away, and they say, hello, Bob, welcome to the company. Now, don't bother us, leave us alone. We got work to do. We got bugs to fix. We got features to develop. So the programmers are just busy typing away, and Bob is kind of sitting there scratching his head and goes around. It's like, what do I do? Programmers don't want to talk to me, but I need to automate. Well, a couple of weeks goes by. He runs into the boss in the corridor, and the boss says, hey, 2 o'clock, my office on Thursday. You need to give a demo about what you've been doing. And Bob says, okay, what do I do now? I've got to really come up with something. And Bob kind of looks around. Programmers don't want to talk to me. I need to automate, and comes up with this, looks around and finds this beautiful tool called Selenium. Now, don't get me wrong. I'm not bashing Selenium here. I'm just bashing the use of Selenium. So the point really is, when we write the test at the UI level, what happens? Well, eventually our tests become brittle, cumbersome. And I'm going to say this leads to what is I would favorably call as pathway to hell automation. I've seen this over and over and over in companies that I've worked with. And I would walk in and they would say, we do all of our automated testing at the UI level. And I would ask them how it's going, and they would say it's going great. And then about a few months later, they would not run any of these tests. I would ask them, why are you not running any of these tests? And they would say, oh, because we made changes to the UI, we made substantial changes, and it quit working. We don't have time to fix it anymore. One such experience I would never forget is a company I was working with, and they said, we are doing all the tests automated at the UI level. I said, that's not a good idea. And they looked at me and said, why not? It's working great for us. Let me show you. One of the developers took me to his office and shows me this application. It's as if a ghost was sitting in front of the application and clicking away and entering things into the keyboard. And I said, how long does it take to run? He said, oh, one full test suite run will take about 12 hours, but that's okay. We still get feedback within reasonable within a day. Well, the point was that this was all the UI developed on the front end. And he went on to say that this was so important to them. They have a team that's dedicated to maintaining this tool, and they've been working on it. And I said, this doesn't work. And he said, no, it works great. And this is the name of the tool. And I said, oh my gosh, if it's really such a great thing, I go speak in conferences. Maybe I should promote this in the world. The world can be a better place using this. Would you mind sharing this with me? He said, oh, of course, I'll be more than happy to. And I said, well, I've got a schedule to come back here in 6 months. When I come back, I'll schedule time with you. Why don't you educate me on this? I will learn about it, and then I'll go start, helping the world get better at it. Well, 6 months went by. I was back in their campus. I went to this developer and said, remember the last time we met, you talked about this. When can we meet this week? And he said, oh, that darn thing. We quit running those tests a few months ago. Somebody changed the UI so much, all the tests broke, and we have no time to fix it. Well, this is a repeat of what I keep seeing over and over and over, and that becomes really hard in the long run. But what is this? Well, the beauty of our field is we'll do absolutely stupid things, but we'll give really beautiful names for those things. This is called the ice cream cone pattern. The ice cream cone pattern is, as you can see here, most of the tests are done at the UI level and not as many at lower levels. And this to me is a disaster in the making in general. And what I would like to see is something a little bit different. And I would say this is yes to automation, but at the right level to the right measure. So in other words, we want to automate, but we need to automate at the right level to the right measure. I believe in rapid feedback loops. I believe in reducing brittlety. And so to me, if I have a UI level, to lift the UI a little bit, that is the HTML or other forms of UI, and then slide the test one level below and write the test at that layer. In the case of a front end, that is lifting the HTML and reaching into JavaScript. This is one of the nice things about Angular or React or Vue, is that testing at the JavaScript level is insanely simple once we learn the right kind of skills to be able to do it. And this is called the test pyramid. So the test pyramid is, it's not that we don't do any test at the UI level. We do. And the test at the UI level is really few smoke tests to know that things are actually connected. Then we write a lot of tests at layers below, at the service layer, the unit level layer, and so on. Same thing for the backend as well. If we write a lot of tests using things like Postman at the REST interface, that I would say is the ice cream cone pattern. Even for the backend, I want a few tests at the UI, at the REST API level, but a lot more tests and layers below at your controllers and services and models and so on, and logic and algorithms. That's where I want to see a lot of tests. So, but why is it so hard to be able to do this? Now, this is one of the things that has intrigued me for a while. I work with absolutely brilliant developers, very capable. I'll give them a particular feature to implement. They would come back and say, I'm done. They would take a few hours or a few days, whatever, depending on the complexity, I'm done. But I would go to the same developers, the smart ones, and tell them to write tests and then to write code. And they would look at me like I'm stupid. And they would say, gosh, are you serious? How could we write tests before writing code? And I would always kind of look at this and say, why are smart developers having hard time to write tests when they're so good at writing code? And so, I mean, one thing to say is, gosh, they're not good, but the evidence is the contrary. They are actually good. So why are they having so much trouble to write it? And I was thinking about it is when I eventually realized something I had not noticed before. And I'm going to ask the question, what is programming? And I'm going to say programming is really, if you think about it, is a series of mini experiments. That's really what it is, isn't it? Does anybody sit down and say, I'm going to write code and then write code and go home? That's not what we do. We take up a problem, we think about it, we write some code, we bang on the desk, we can't get it working, we try to look up some APIs, and then we question, we talk to colleagues, and then we say, oh my gosh, I think I have a better understanding of this, and we discover. So it's a series of mini experiments where we discover to go from a set of unknowns to a set of knowns. That's basically what we do, where we discover to go from a set of unknowns to a set of knowns. Now, when you go to somebody and say, write tests before writing code, you are telling them you don't have to experiment. You don't have to really figure these things out. You can know everything, go write the code, and they look at us like we are idiots. So what do we do to solve that particular problem? And the answer to that question is to really understand some of the reasons to do it again, and then come back and find a way to approach it. First of all, when you hear somebody say, this code is really hard to test, what they really are telling you is a euphemism. What they really meant was that the design of this code sucks. So to me, testability is a design concern. If a code is tested, it is designed better. So we want to really drive that test. But it is really the set of unknowns I talked about, and it's really hard to test these unknowns. And so what do? One of the things is to employ this act of spiking. And once I realized it, it became a lot easier for me, not only do it for myself, but to help my teams as well. First of all, take small steps, divide and conquer, but most important, spike to learn. So what I mean by that is, when I'm given a problem, I'll give you an example. I was asked to develop an application using Amazon S3 a few years ago. But that was the first time I had used Amazon S3. And I freaked out. Oh my gosh, I've never used it at that point. How do I write tests on it? And the little devil in my head says, don't worry about writing tests, go get the work done. And I knew that this was not going to be a good thing. So what I said to myself is, no, I'm not going to write the code in production without test. But I don't have a clue what to do. How do I approach it? So I went on and looked at all the tutorials, APIs, and learned about how to write code. Then I went on to create a prototype. And I do this quite often as a very distinctive active step. I'll leave my application here. I would run to a separate directory. I'll create a random prototype. And the prototype is doing something similar to what my needs are in my application. And once the prototype works, I have the discipline to delete the prototype. The prototype has helped me to learn to convert a series of unknowns into knowns. Now that I know the API, I jot down, write some notes about it, delete the prototype, I come back to my code. Now I write test and write code. Now, this whole thing took me about 4 hours. Now, you may say, oh my gosh, Venkat, you took 4 hours to implement with test what you would have implemented in 15 minutes. I totally agree with that. Isn't that a waste of time? The answer is no. And the reason it is not a waste of time is twofold. One, that was 4 hours about 6 or 7 years ago. In all the time since then, I've used those testing techniques I learned to test into Amazon S3 so many times over and over. I have changed the code so many times, I've gotten quick feedback on the code. I've helped my clients write better tests because that experience of 4 hours taught me a lot more to play with code and write tests in certain situation more than what I had understood before. That skill has been very helpful as well. So the spike to learn is extremely important. So is JavaScript really verifiable? And the answer is absolutely yes. In fact, this intrigued me so much, developers being interested in it, I wrote this into a book actually. So on the HTML side, we can write some UI level tests using Selenium or Protractor. Again, I'm not saying don't use those tools, but use them to a minimum. And client side, 25 tests, for example, and the routers and the models and validation, 41 tests, talking all the way down to a database. So the point really is we can write tests in every single level, and you can see the test pyramid sitting right there. Now, what about, integration test? So is integration, I'm going to say integration test not, necessary? And I'm going to say absolutely it is necessary. I'm going to say integration test is to testing as salt is to a meal. So what does that really mean? Salt is very important for meal. If I give you a meal with no salt, you're going to say, eat it, and you're going to be like, gosh, this is bland, and you're going to just put it away. Or if you're at a guest house, you're going to say, well, thank you very much for the food. It was great, but I'm not going to be able to eat anymore. You're being polite because that's not palatable. But if I give you a meal made out of salt, I give you a plate of salt and say, here you go, have your meal, you're never going to come back to visit me again, isn't it? Well, just like a salt has to be in the meal to a very small proportion, integration testing has to be to a small proportion. Don't create your test without integration test, but don't create a test with integration test alone. Just like, meal without salt is no good, a meal of salt is no good either. And that is a way to really think about it. And so to be able to test drive the applications, we can definitely do that. It's really about learning the practices as to how to do this. So it takes discipline. And that is the first thing I want to emphasize is the discipline. When I sit down to write code, what really helps me on a daily basis is the discipline. I can't tell you how many times I tell my colleagues, hey, I'm going slow, but I'm glad I'm going slow because when I'm done with this, I'm going to be really fast. Because when I come back to make changes, I've got this feedback loop. That is the discipline. It's the maturity to say it's okay to go slow here because we're going to gain speed with the quality and the feedback mechanisms we are building in place. So discipline. It takes time. And that's one of the other things I want to emphasize is when I sit down to write software, I invest time. I am not there to get it done quickly and run. I got here, I'm a professional. I'm going to invest the time to create quality because I want to really be proud of what I do, but also be able to create something that's maintainable by me and the rest of the team. And it's a skill. And there are times you take a problem, you invest your time into figuring out how to really write tests for it. It's really a skill. I started knowing nothing about it. I'm able to write tests today, not because I'm any smarter. To the contrary, I'm just about the same average person I was ever. But it's what is the time I've spent to really build that skill over time. And it's a culture of testing that we build around our teams because we all are extremely social beings. We learn from each other and try to do what others around us do. So when we have a culture of testing, we do that a lot more. I'm going to say automated testing is the software equivalent of exercising. And I say this because if I ask a team of people who exercises, most of them, will say that exercising is good for health, but very few people may actually do it regularly. Why is it? Because we all have our excuses. I got this proposal to write, I've got this code to write, I got this bug to fix, I got this book to finish, whatever that could be. And we give these excuses. But software automation testing is a software equivalent of exercising. Most people will tell you, yes, it's important, it's useful, but it takes discipline to actually do it in the long run. I'm going to say we are really in the year 1820 of software development. What do I mean by that? Well, it turns out if we go back and read about history, in year 1820, the hospitals around the world, especially in the UK, there was a lot of death after surgeries. If a friend of yours comes to you and says, I'm going to have a child, should I go to the hospital to have the child? You may say, bathtub is better than going to the doctor's office, the hospital. Why? Because the infection rate was very high. If people survived surgeries, they died out of infection. And until they were thinking about it, and there's a guy named Semmelweis who went around telling doctors that there was germs they were carrying. And back in time, doctors, really good doctors, had a lot of blood on their coat. It's unimaginable by today's standards. But doctors walked around with blood on their coats. And these doctors were proud, more blood on their coat because they did more surgeries. And Semmelweis said, you doctors are killing your patients because of the germs you carry. And this was the time before they could really see the germs through microscopes. And Semmelweis, poor guy, was speaking against authority. He was sent to a prison. Eventually, he died in the prison. Well, several years later, a bunch of other doctors came along, most notably Joseph Lister and Louis Pasteur, and they came along and they said, hey, this person, Semmelweis, was actually correct. He actually pointed out to germ theory, and what they did was they would sterilize the things they used for surgery, and their patients died a lot less compared to a lot of other languages. And Joseph Lister especially was very instrumental in a lot of today's practices that we use because he identified that doctors were the carriers of germs between people. And I relate to this in software development because we are creating a lot of problems that we are continuously solving. And by using some discipline and practices, we can reduce some of those problems that we create for ourselves in the long run. So we are practicing a beautiful craft. I love programming. I've been a programmer for several decades, and I might actually be the programmer for the rest of my life. And the reason is it's a beautiful craft. I really enjoy this aspect of thinking something and realizing it in code. It's a beautiful profession that we are living in. And to be a programmer is a very, it really is a very intellectual, endeavor. It meets our curiosity. It piques our interest. We like to crank out code and see it come to life and create solutions. We can solve very many problems using programming. It's a beautiful craft, as we know. Let's go turn that into a wonderful profession, because as professionals, we want to take pride in what we do. We want to create something that's sustainable. We want to create something that's maintainable. We want to create something that's economical. We want to create something that can be developed and maintained by other teams over time and other people over time. So it is our professional responsibility to really create software that can be maintained within reasonable economic cost. After all, the goal of agile development is to really create something that can be changed very efficiently over time. And that's what we need to strive for, is to bring that discipline into what we do. Thank you so much for your time. I hope that was useful. Really appreciate you being around for this session. Thank you.